Next, we'll see how to simplify Boolean algebra. Simplification of There are various methods by which we can simplify the Boolean expressions. We'll discuss on three popularly used simplification method. Number one, Algebraic method. Number two, Carnot method. Sometimes it is called K-map. Carnot is abbreviated as K-map. Number three, Quine-McCluskey method. First of all, we'll see the algebraic method for simplification of Boolean algebra. In order to simplify any Boolean function by algebraic method, we'll employ all the rules and laws of Boolean algebra that we learned so far. Let us see an example. Suppose we have a function x prime y z plus x prime y z prime plus xz. Now, how can we simplify this portion? We can take common x prime y from these two sets of variables. Then we'll have z plus z prime and xz. We know z plus z prime will return us 1. So x prime y plus xz. So the expression is reduced to only two terms and can be implemented with gates. Let me show you the implementation. We have x, y, z. It's x prime. We'll get x prime here. Y. X prime y will be ANDed, and xz will be ANDed, and finally the output will be all together and we'll get the function f. Let us see another example. This is one of the examples. xy plus x prime z plus yz. How can we simplify this? Let's keep solving. xy plus x prime z in yz. If we take x plus x prime, there will be no change because we know x plus x prime equal to 1. We can write xy plus x prime z. Here we need to place plus xyz plus x prime yz, which is equal to, if we take xy common from these two terms, xy 1 plus z plus x prime z common from these two terms, x prime z will get 1 plus y, and 1 plus z will return you 1, 1 plus y also return you 1. Finally, we will get xy plus x prime z. This is the simplified version of this function. Next, let us see another example. We have ab plus a into b plus c plus b to b plus c. Let us simplify this expression. We can write ab plus ac plus b into b will return you b plus bc. We know a plus a is always a in Boolean algebra. If a equal to 1, 1 plus 1 will return you 1. If a equal to 0, 0 plus 0 will return you 0. So ab plus ab will give you ab plus ac plus b plus bc. Now if we take b common from here, we'll get 1 plus c. 1 plus c will always return you 1. So we have b plus ab plus ac. Next, if we take b common, we'll have 1 plus a plus ac. That will return you 1 plus a equal to 1. So we can write b plus ac. So this is the simplified version of this expression. I hope you have understood the algebraic method. What you need to have more practice by simplifying different algebraic expressions. I'll give you an assignment where you'll find a lot of problems to simplify the Boolean algebra using algebraic method. Next, we'll learn the dual form of Boolean expression. What is dual form? Suppose if we have a plus 0 is equal to a, if this expression is true, we know this is true, then using dual form we can get another expression where we need to convert this OR sign to AND 0 to 1. That's all. If we have AND sign, that is needed to be converted to OR, and if we have 1, that is needed to be converted to 0. So the dual form of this function can be written as a will remain same, all the variables will remain same in its current form, or will be converted to dot, 0 will be converted to 1 equal to a. If this is true, this function is also true. Again, using duality theorem or dual form, if we know a plus 1 is equal to 1, then this is one of the expressions. Then if we use the dual form, a will remain same, plus will be converted to dot, 1 will be converted to 0, then 1 will be converted to 0. So if this expression is true, then this expression is also true. We can get this expression from the upper expression using duality theorem. Again, in one of our previous examples, we found that xy plus x prime z plus yz, the simplified version becomes xy plus x prime z. Using the duality theorem, we can get this is also true, x plus y, that means AND will become OR, this OR will become AND, x prime plus z, this AND becomes OR, and this OR will become AND, again y plus z equal to x plus y into x prime plus z. If this is true, then this is also true. We get it using duality theory. Next, we will learn some ways of expressing Boolean functions. First of all, the sum of product, which is abbreviated as SOP form. When two or more product terms are summed by Boolean addition, the resulting expression is called sum of products or SOP form. Let me give you an example. Suppose we have a function f equal to ab plus abc. We have one product form, another product form, and they are summed up. If we consider another function, suppose this f1, another function f2, abc plus cde plus b prime c. This is also sum of product form. We have product term, and product term. They are summed up. Remember, this is not sum of product form. For example, this one, a into b plus c. We have sum term and product term. We are coming to this point later on. Anyway, a SOP expression can contain a single variable term as well. For example, f4 equal to a plus a prime bc plus bc prime. So this is sum of product form, and we may have a single variable term. Next, we'll discuss the product of sum form. Product of sum, which is abbreviated as POS form. When two or more sum terms are multiplied, the resulting expression is called product of sum or POS form. Let me show you some examples. Suppose f1 equal to a prime plus b into a plus b prime plus c. This is one sum form, this is one sum form, and combinedly they are ANDed. Again, we can have a plus b, a plus b prime plus c, a prime plus c. We have product of sum form. Now, for this function, if you're asked what type of function is this, a into b into a prime plus c. This is neither SOP form nor POS form. Okay, this is a mixed term. We can convert it to SOP form by multiplying like this way, a prime b plus bc. Now this is in SOP form, but this is neither SOP nor POS. Next, we'll start our discussion on standard SOP, that means sum of product form. What is standard sum of product form? A standard SOP expression is one in which all the variables in the domain appear in each product term in the expression. Let me show you an example. Suppose we have f equal to a b c plus a prime b. This is SOP form, sum of product form. And how many variables are there? There are 3 variables, a, b, c. Now in this product form, we have 3 variables present, but in this product form, we have only 2 variables present. One is a, another is b. Though it is in complemented form, but we have a and b, but c is missing here. So we can say this is SOP, but this is not standard SOP. If we want to make it standard SOP, then we must have all the variables present in each product term. Now if I write another function, suppose this is f1, f2, a prime b c plus a b prime c plus a prime b prime c. Now this is SOP, sum of product form, and this is also a standard SOP form because in each product term I have all the variables present. Now remember one thing, each standard SOP term, each product term in standard SOP form, sometimes named as Minterms as well, Minterms. I'll come to the Minterms and Maxterms definition later on, but for the time being, you know that this is one Minterm, this is another Minterm, and this is another Minterm. Remember, this is not the Minterm. This is not Minterm because we have 3 variables, there are only 2 variables present here. So each product term of standard SOP form, sometimes named as Minterms. Now let's see how to convert a normal SOP form to standard SOP form. So converting SOP to standard SOP. How to do that? Suppose we have a function f which is a b c. Let's take this function plus a prime b. This is SOP but not standard SOP. How can we convert that? First of all, we need to find the product term where the variables are missing. Here we have one missing variable. So what we can do, we can write a b c plus a prime b as it is. And what is the missing term? Missing term is c. So we can multiply c plus c prime with these variables because that will not cause any problem. C plus c prime will return you 1. If 1 is multiplied with any product term, that doesn't change the value of that product term. So we can write this. So next we can write a b c plus a prime b c plus a prime b c prime. So now if we examine, this is the standard SOP form of this function. We have all the 3 variables present in each product term. Now let's say another example. Suppose we have f equal to a plus b prime c. Now here we have 2 missing variables and here we have 1 missing variables. There are total 3 number of variables a, b, c. Now let's start converting this SOP to standard SOP. First of all, let's take b plus b prime, the first missing variables, and a plus a prime for the second term into b prime c. We can write ab plus ab prime plus ab prime c plus a prime b prime c. If we multiply c plus c prime with ab and c plus c prime with ab prime, we'll get abc plus abc prime plus ab prime c plus ab prime c prime plus ab prime c plus a prime b prime c. So this is the standard SOP form of this SOP equation. I hope it's clear to all of you. Now let's see how can we get standard POS form. A standard POS expression is the one in which all the variables in domain appear in each term in the expression. For example, if we have a function like this, a plus b prime into a prime plus c into a plus b plus c. How many variables are there? There are 3 variables, a, b, and c. But in each sum term, we do not have all the variables present. Here we have one missing variable, that is c. Here we have one missing variable, that is b. So this is POS form, but this is not standard POS. Now if we have another function, f2, a prime plus b prime plus c, a plus b prime plus c into a prime plus b plus c prime. Now we can see this is standard POS form because in each sum term all the variables are present. We have a, b, c here, a, b, c here, and a, b, c here. At this point I want all of you to remember that each sum term in standard POS form is sometimes referred as Maxterms. Maxterms. Here this is one Maxterm, this is another Maxterm, this is another Maxterm. This is not Maxterm. This is not Maxterm because we have one missing variable here, that is b. So this is Maxterm, and this is the representation of standard POS form. Now let's see how can we convert POS to standard POS. Converting POS to standard POS. Suppose we have a Boolean function f equal to a plus b prime plus c, e prime plus c plus d prime, a plus b prime plus c prime plus d. Now how many variables are there? There are 4 variables, a, b, c, and d. We have one missing term here, that is d. We have one missing term here, that is a. We do not have any missing term in this sum form. So how to deal with that? Before I proceed with this problem, let me show you one of the laws that we are going to use here. That is, if we have a plus b prime b, this can be written in this format, a plus b into a plus b prime. We can have a proof. Suppose if we take right hand side, a plus b into a plus b prime, if we multiply a into a, will return you a into b prime plus a into b plus b into b prime. Now b into b prime equal to 0. So we can say, if we take common, 1 plus b prime plus b, this value is equal to 1 because 1 plus any variable will return you 1. So finally we'll get this is equal to a. And in the left hand side we have a plus b prime b. This b prime b will return you 0. So we have a. So right hand side and left hand side, they are equal. So we can write a plus b prime b, which is equal to a plus b into a plus b prime. Now how to solve this function? We have a plus b prime plus c, one term that is missing. What we can do from here, we can write in the next line a plus b prime plus c plus d into d prime. If we add d into d prime, actually the value of d into d prime is 0. If we add 0, there will be no problem in this sum term. So we can do this. Again, we have one missing term, that is a. So we can write a into a prime plus b prime plus c plus d prime into, we have a plus b prime plus c prime plus d. Let me separate this part because this is not part of our problem. Now if we consider this portion as our x For example, this is x, then x plus d into d prime can be written as, using this formula, x plus d into x plus d prime. So we can write x equal to a plus b prime plus c, a plus b prime plus c plus d into a plus b prime plus c plus d prime. Similarly, we can write a plus b prime plus c plus d prime into a prime plus b prime plus c plus d prime. And finally, we have a plus b prime plus c prime plus d. So this is the standard POS form of this POS format. Next, we will start our discussions on Minterms and Maxterms. We know in standard SOP form, each product term is named as Minterm, and in standard POS form, each sum term is named as Maxterm. So if we have three variables, which are x, y, z, using three variables, let's see what are the Minterms and what are the Maxterms. So let's make a table. We have x, y, z. Now, using three variables, how many combinations can we have? We can have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and finally 1, 1, 1. Total 8 combinations. Now, if we write all the Minterm combinations for three variables, we can have x prime, y prime, z prime. This is the first combination. Now you can see if x equal to 0, y equal to 0, and z equal to 0, what is the value of this term? This term will be 1, because if x equal to 0, x prime will be 1, y prime will be 1, and z prime will be 1 for y equal to 0 and z equal to 0 respectively. And if you multiply 1 into 1 into 1, we'll get 1. But for all other values of x, y, z, we'll get 0, because if x equal to 0, y equal to 0, these two values are 1, but for z equal to 1, 1 prime will return you 0. So finally, 0 is multiplied with 1s and we'll get 0. You can check it. For all other values, we'll get 0. Only for this combination, 0, 0, 0, x prime, y prime, z prime will return us 1. So using three variables, we can have this one product term, which is called Minterm. Again, for 0, 0, 1, x prime, y prime, z, for this value we'll get output equal to 1. For other values we'll get output equal to 0. In this way, if we keep writing x prime, y, z prime, x prime, y, z, x, y prime, z prime, x, y prime, z. Actually, how am I writing? Whenever I have 1, I am just writing x. Whenever I have 1, I'm just writing y. And whenever I have 0, instead of writing z, I'm just putting a prime sign so that I can get 1. Our main target is to get 1 for each value. Okay, so that the multiplications of three variables gives us equal to 1. So here x, y, z prime, and this is x, y, z. So these are the Minterms for three variables. So these are Minterms. Now generally Minterms are represented by symbols as well. Symbols. The symbol is very simple. For Minterm, we use small m, and for the zeroth value we put 0. This is the corresponding binary value of decimal 1, so we put m1 here, m2 here, m3 here, m4 here, m5 here, m6 here, and finally m7. Now remember, if you would have 4 variables, then you would have 16 combinations. For 16 combinations, you would have total 16 symbols, m0, m1, m2 up to m15. Now if you are asked what is the corresponding Minterm with 3 variables having symbol m6, now what is 6 here? We know the 6 has corresponding binary value which is equal to 1, 1, 0. If we know 1, 1, 0, then if we know the variables, it will be equal to x, y, z prime. So this is the corresponding min term of M6. If you are given any min term symbol, I hope you will be able to extract original product term using the corresponding variables. Suppose we have 4 variables A, B, C, D. These are the 4 variables. Now if you are asked what is the corresponding min term for M14, we know 14 has corresponding binary value which is equal to 1110. As we have the variables presented by A, B, C, D, so we'll write A, 1, B, C and D prime. That's it. So M14 will have corresponding product form in this format. Before we proceed to Maxterm, let's see how can we express function in terms of sum of minterms. Suppose we have a function f equal to x prime y prime z prime plus x prime y z prime plus x y prime z plus x y z. This is a function. So you can write in this fashion as well, x prime y prime z prime, meaning 0 0 0. For 0 0 0 this value will be 1. So this x prime y prime z prime for 3 variables, it has a symbol m0 plus 0 1 0. It has a symbol, actually 0 1 0 has corresponding decimal value which is equal to 2. So I can directly write m2. In this way we can write m5 plus m7. This is also one of the ways of representation. We are writing this function as sum of minterms. Again, this function can be represented in this fashion as well. If x, y, z, we have 3 variables, we put sum sign, sum of minterms 0, 2, 5, 7. If you are asked that extract the function from this notation, so how can you get that? We have f, x, y, z. That means there are 3 variables and the variables are named as x, y, z, and we have sum term. So it will be sum of minterms 0, 2, 5, 7. So minterm 0, minterm 2, minterm 5 and minterm 7. So you can write f equal to, what is the corresponding binary value of 0? 0 0 0 using 3 variables. So 0 0 0 means x prime, y prime, z prime plus, as we are using summation sign, so we need to use plus because it's sum of minterm. What is the corresponding binary value of 2? It's 0 1 0, so we can say x prime y z prime. What is the corresponding binary value of 5? It's 1 0 1, so we can say x y prime z. Finally, what is the corresponding binary value of 7? It's 1 1 1, so we need to write x y z. So this is the function in sum of minterm form. Now if you are given a function not in standard sum of product form, rather the function is given in this fashion. Suppose we have 3 variables x, y plus x prime z. The total number of variables is 3, x, y and z, but we do not have all the variables present in each term. So before we convert this function to this format, we need to convert it to the standard SOP form. In order to convert it to a standard SOP form, we know the procedure. X, y, we need to multiply z plus z prime, the missing term is z here, plus x prime z, y plus y prime. Finally, we can write x, y, z plus x, y, z prime plus x prime, y, z plus x prime, y prime, z. Now this is equal to 1 1 1. 1 1 1 means m7. This is equal to 1 1 0. 1 1 0 means m6. This is equal to 0 1 1. 0 1 1 means m3. And finally, this is equal to 0 0 1. 0 0 1 means m1. So you can write a function in x, y, z format. We have the function is equal to summation of minterms 1, 3, 6, 7. That's it. Now let's see the maxterms. Maxterms are representation of some terms of standard POS form. Here in maxterm, instead of using AND, we need to use OR because we are using sum term. So whenever we have x equal to 0, y equal to 0, z equal to 0, the target was to make 1 for Minterms. Suppose if x equal to 0, y equal to 0, z equal to 0, x prime, y prime, z prime will give us 1, for other values will give us 0. So this is the unique case. For Maxterm, the unique case will be to make the output equal to 0, because for only one combination we will get the output 0, as we are using sum term, and that means OR condition. In OR condition, for one unique combination we will get the output equal to 0, for other combinations we will get output equal to 1. So for Maxterm case, our target is to make the output equal to 0 for each combination. For example, x equal to 0, y equal to 0, z equal to 0. In order to make output equal to 0, we need to have x plus y plus z. If we have x equal to 0, y equal to 0, z equal to 0, only for these values the output will be zeros. But if you take all other values, as one of the variables is 1, so this value will become 1, because though we have 0 plus 0 for this case, suppose x equal to 0, y equal to 0, x equal to 0, y equal to 0, as one of the variable is having one value, so 1 plus any value will return you 1. So for only 0, 0, 0 you will get 0 output. So in the Maxterm representation, our target is to make the combinations in a unique way so that we can get 0 output for that unique combinations. Again, for x, y, z equal to 0, 0, 1, the term will be x plus y plus z prime. For this case, x equal to 0, y equal to 0, and z equal to 1. Z equal to 1 will give us z prime equal to 0. So 0 plus 0 plus 0 will give us 0 output for only for this input 0, 0, 1. For other inputs, it will be 1. Similarly, we can write x plus y prime plus z. Here, the way of writing is opposite to our Minterm case. When we have any variable equal to 0, we'll write corresponding variable. Whenever any variable is having 1, we'll write the complement of that variable. So here, x plus y prime plus z prime, x plus, actually x prime, y plus z, x plus, this will be x prime plus y plus z prime, x prime plus y prime plus z, x prime plus y prime plus z prime. So these are the Maxterm representation for 3 variables. Maxterm. Next, the symbols. The symbols are represented by using capital M, and the positions are written here. M0 is the corresponding Maxterm for 0 value. M1, M2, M3, M4, M5, M6, M7. So these are the Minterms and Maxterms for 3 variables. Remember, 3 variables. If you understand the Maxterm and Minterms for 3 variables, I hope you will be able to get the Minterm and Maxterm for 4 variable, 5 variable, even 6 variables. Whatever the number of variables are there, you'll get the corresponding Minterms and Maxterms. A function can be represented by product of Maxterm form as well. For example, if we have a function x, y, z, which is equal to x prime plus y plus z into x plus y prime plus z into x prime plus y prime plus z prime. Now this function can be represented in this format. For this, what is the corresponding binary value of this Maxterm? This is x prime y z. X prime means 1 here in Maxterm case. So we have 1, 0, 0, and 1, 0, 0 has corresponding symbol, that is M4. M4. Here we have 0, 1, 0. 0, 1, 0 has corresponding Maxterm notation, which is M2. Here we have 1, 1, 0. 1, 1, 0 has corresponding Maxterm notation, which is equal to M6. So this function can be represented in this fashion as well. Also, this function can be said x, y, z. This is the product notation, product of max term, where we have 2, 4, 6. These are the product of max term from. If you are given a function in this fashion, you can extract this. If you are given a function from that given function, you can also write the function in this format in terms of product of max term form. Now, if you are given a function which is not a standard POS form, in order to convert it to product of max term form, you need to convert that function to standard POS form, then write the corresponding max term notations. Conversion of POS to standard POS was shown earlier.